I'm going to talk on discover the easiest part to use Yugabyte Cloud, which is a distributed database as a service offering from Yugabyte. There is one always a question in discussion from the field or our customers is, can we move our existing applications to use Yugabyte DB as a service, or for the new application, we'd like to use Yugabyte DB for it. Should we use Yugabyte Cloud database or should we try to host Yugabyte DB ourselves? Before moving to it, let me introduce myself. My name is Amol Boite and I'm working as a senior solutions architect for Yugabyte. In my prior professional experience, I worked for Hitachi, BMC, Harman, Zorian, Sybase on different enterprise products and solutions. Agenda of this session is first, I will walk through Yugabyte product offerings and then go through what is distributed database as a service. Then I will talk on why any customer can choose Yugabyte database as a service offering to their cloud native applications effortlessly with Yugabyte Cloud. Then I will walk through hands-on demo. And lastly, I will show one customer case study, which is using Yugabyte Cloud. First, let's see what is Yugabyte distributed database and cloud database as a service. Before that, let's see what Yugabyte has different product offerings. First one is Yugabyte database, which is 100% open source under Apache 2.0 license, which is self-managed. Second offering is Yugabyte platform, which is an enterprise product which provides excellent UI with the orchestration and manages Yugabyte DB universes or clusters. And third offering is Yugabyte Cloud, which is fully managed public database as a service. Now let's talk on Yugabyte Cloud. Yugabyte Cloud is effortlessly distributed SQL for your cloud native applications. Yugabyte Cloud is fully hosted and managed offering of Yugabyte DB, giving you distributed SQL database for global applications with no operation overhead. Yugabyte DB is an open source Postgres compatible, highly resilient, scalable distributed SQL database, and Yugabyte Cloud is Yugabyte database as a service. You bring the application and we handle the operation. You can deploy database clusters globally to any of the regions. Your preferred cloud provider supports, and you can deploy database clusters and flexible geo distribution topologies to meet your application needs. Yugabyte Cloud makes your database operation effortlessly, allowing you to focus on building great applications. Now we're gonna compare Yugabyte with Postgres and Google Spanner, along with talk on Yugabyte architecture. Google brought an idea of Google Spanner to have SQL execution against a global relational database while maintaining consistency. Yugabyte DB brought the idea to an open source database, in fact, one compatible with existing databases, including Postgres SQL and Cassandra. And here we can differentiate between the Google Spanner and Yugabyte DB. On the Yugabyte architecture side, DocDB, which is Yugabyte distributed document store, common across all APIs, which is built using a custom integration of Raft replication, distributed ACID transactions, and RocksDB storage engine. DocsDB does sharding, replication, fault tolerance, and distributed ACID transactions. That is, the architecture are all based on the Google Spanner design. Yugabyte DB support two flavors of distributed SQL. First one is YSQL, which is fully relational SQL API that is compatible with API of the SQL language in Postgres SQL. YSQL has its roots in the Cassandra query language. Let's move on to why to choose Yugabyte DB as a service to host cloud native applications. First, we will discuss on three main factors you want to think about when you are evaluating the cost of ownership of any piece of software. Sometimes this is called total cost of ownership or TCO. And it broadly applies to any kind of software in this particular case. We'll apply it to database. So the three factors are: one, hardware cost; two, software cost; and three, broadly, that we call as operational cost. First one is hardware cost, include machine storage, IOPS, load balancer, and egress and ingress traffic. Second is software cost. Now, software costs are typically pretty straightforward, right? This is the license you pay if you want to run a database yourself. Finally, third category of cost I want to talk about is operational cost, that is including human capital, support, and domain expert. So to address all the key factors and challenges, Yugabyte Cloud Database built that expertise. You know a little bit about database, but you are not spending all your time thinking about what is the right kind of machine, what is the right kind of storage I should be using. No need to think about replication or sharding or scaling. These are all things that are usually taken care by Yugabyte DB Cloud Database without having domain expert. On the other side, when there are issues that come up, if you are using a Yugabyte Cloud Database, there is a support that comes up. You can open a support case. You can also sometimes purchase higher levels of support. There is a technical person in the company that would help you solve the problems. Yugabyte Cloud Database provides backup, disaster recovery. Yugabyte has site reliability engineers to monitor and maintain our cloud customers' databases. Hosting database on the cloud of Yugabyte gives an opportunity to the company to spend time on the core kind of competitive advantage of your company, which is serving your customers. Save precious engineering time for building core application. Let's have a hands-on demo which will showcase to connect cloud native web application to Yugabyte Cloud Database, and we'll talk through Yugabyte Cloud Database administration activities as well. Okay, for this demo, I'm giving demo of a sample web application named Yuga Telecom Telesubscribers, accessible using any of the web browsers. This application will show us a web page with a pie chart of number of subscribers for the Yugabyte Telecom company for 5 countries. This web page is developed in React.js web framework. I'm using Apache web server to serve this web application. However, for the demo, I'll start native React.js web server and Django backend API server. This web application is pulling the data from Yugabyte Cloud Database using APIs developed using Django Python frameworks. For the data population, I'm running one sample data simulation Python script, which will call Python post API, which insert data of the subscribers, which is random database population per country in the Yugabyte Cloud Database, which is 3 availability zone database configured using the Yugabyte Cloud. Okay, let's move on to the hands-on lab. In this hands-on lab, first we will look into the database side, then we'll look into the API layer, and third, we will look into the web application layer. People who are new to Yugabyte Cloud, they can sign up using the provided credential, their name, email address, and needed information, and start using the Yugabyte Cloud. Once user will log in into the portal, user can see the getting started page where user can see the quick guide, product overview, and the documentation where user can see all the details of the Yugabyte Cloud. The next tab is clusters. So this is important step for the user to decide what kind of cluster he want to deploy on the Yugabyte Cloud. So if it is the staging or development environment, user can create a simple 3-node cluster and use it. But for the production deployment, it is very important to first evaluate the database. So user can see what kind of source database is there, what is the need of the latency of the application, what are the IOs that application is needing. It could be random read, random write, sequential read, sequential write. Then how much disk capacity is needed. So user can also benchmark the database on the Yugabyte Cloud before moving into the production environment. So to create the new cluster, click on the Add Cluster tab where user can see the free tier and the paid tier for Yugabyte Cloud. For the production, it is needed to scale your cluster on demand. Uh, for this type of deployment, automated and on-demand backups are provided. Dedicated VPC for network isolation is also provided. Then in the cluster setting, user has an option to deploy it on the AWS or the GCP platform. Azure is currently not supported, but it will be supported soon. Then region has to be specified. It is important to specify the region which is near to the application tier. User has to specify the fault tolerant with 3 nodes minimum spread across multiple availability zones with a replication factor of 3. And deploying into the dedicated VPC improves the network security, reduces network latency and cost. Click on the next. Then user can use the default credential or add their own credentials and click on the cluster creation. YB cluster demo is the one which I have created before. And you can see different tabs over here. So I'll be coming back on this tab. So first I will show you how to connect to the cluster using the Cloud Shell. So basically I'll be showing the database which I am using for the web application, where I'll be showing the table structure and the query which I'm using into the API, which is being fetched from the application layer. So I'm using default Yugabyte as a database. So this is the table actually I'm using for the web application, where all the subscribers information is there. Okay, so this includes subscriber number, subscriber name, and the country. Subscriber number is the primary key for this. And lastly, I'll show you the query. So I'll be again coming back on the screen to show you once I will be starting the load into the database, and which will be reflected into the web application side. So for the client shell, user has to first download the CA certificate to connect to a particular database. So in our case, we'll be connecting from the Python APIs to the database. So that I will be showing here. So user has to download the CA certificate. Okay, so that's it from the database side for now. Now let me jump onto the API tier, where API is using the get and post method to retrieve the data and insert the data into the database. So currently I have two API which you can see on the Postman. First API is to see to get the subscribers report. So if I'm sending this API, I'm seeing for these 5 countries how many subscribers are here. Okay, so this is the get API. The second API is the post one. So where I'm inserting data of a subscriber name and country, and where subscriber number is auto increment in this table, where I'm using those APIs. So let me move into the actual Python Django framework. First, I'll be showing the setting.py, where I'm actually providing the database credentials of the database which we have created on the Yugabyte Cloud. Okay, so important thing to note here is that user has to provide the host name. So if we go here on the portal, you can see this is the host name which we have seen here. And these are the user credential. Actually, this has to be passed in the configuration. Then the next important thing is the downloaded certificate, which from the Yugabyte Cloud, that has to be copied on the application server. So that is root.crt. So this is about the database connection setting. The next one is urls.py, where I have the get and post API. So subscriber report is the actual API which is calling the Python function get subscribers country count report, and this one is the post API, that is subscribe reg subscribers country. So if we look at this now, what is there inside the API? So if you can see under the views.py, I have get and post API. In the get API, I'm actually aggregating the subscribers based on the country. And in the post API, I'm actually inserting the data. So this is what the API code is. Start to insert the data into the database. So for that, I have created one create bulk.py script, which is actually generating the random database into the subscribers table. That means insertion will be happening for 5 countries randomly. Let me run this script, python create bulk.py. Now what this script will be doing, this is the subscribe registration API, which is the post API. So this script is going to call this API and run it for 10,000 times. So if we go here on the Python, so if you can see the post API is continuously running here. Okay, so which is actually inserting a record into the Yugabyte Cloud database. Okay, so that is from the API tier. Now let's move on to the web application side. On the web application side, I'm using React.js as a web framework. So which is under the YB Cloud UI folder. And if you can see backend API is under the backend APIs folder. So here I have app.js where I'm specifying the relevant API. So this is the backend server, that is the API server running on this port. And I'm using a single API, that is subscribers report over here, which is actually calling a get API, which is again calling a aggregation query on the database and fetching the result. That's what we have seen over here. We are seeing this data, right? So as we have started the load, we can see here the API data is changing continuously. So data is inserting for all the countries randomly using the bulk load Python script. Now we'll go on the web application directly. So let me pull all the things in one screen. Okay, so if you can see, this is the web application developed in React.js page. So this is a simple single page application where we are seeing the data of all the countries and the subscribers for a particular country. If we hover the mouse on a particular color, we can see the count. Currently count of India is 8162. This is what we can see here. Let it refresh. So this page is refreshing every 5 seconds. 8173. Okay, so at the back end, if you can see the database query, we should be able to see the exact count on the database side. Okay, let's run this query again. Let me run this query again. 7208, and let me run the count. Okay, currently 27,675. Okay, now it is changing. Okay, so that means the data which we are generating from the Python API is loading into the database. On the same time, the web application is pulling the data from the database using the APIs. So this is what, at the high level of the demo which I wanted to showcase how the web application tier is talking to the API tier and how API tier is working with the Yugabyte Cloud database. Okay, now let's move on to the Yugabyte Cloud administration things on the Yugabyte Cloud. Okay, since so first we'll look into the cluster. Okay, so this is the cluster which currently we are using it. If you look at in the overview, you can see the key matrices including operations per second, average latency, CPU, disk usage. So those matrices can be visible over here. We can see the tables which are being used. Now you can see we are using this subscribers table, right? So this is 5 MB. So data will be, whatever data will be inserting. So accordingly, this table size will be reflected over here. On the node side, we can see these are the 3 nodes, but we can, customize those nodes as and when needed using the edit infrastructure. So we can increase the nodes, and accordingly, you will see the cost of this deployment. On the backup side, if you can see, we have the schedule backups where we can schedule the backups as well as in the policy setting, we can change using the custom option, and we can run a backup at a particular time. Next, move into the performance where we can see more matrices that include the YSQL operations per second, then CPU disk usage, and we can have more options like, once we go in the edit option, we can get more matrices on the screen. On the activity, we can see whatever network related and the cluster related activities we can see here. Inside the maintenance, user can have the preference to be set at a particular day of the week and time. There can be a maintenance activity on the Yugabyte Cloud. So user can specify this thing. And the last one is of the setting. So user can edit the infrastructure as and when needed. User can provide the network setting using the network access tab. So IP allowed list can be modified over here. Okay, now let's move on to the alerts where user can get the notification of the cluster database. Okay, let's move on to the network access. So there are two things over here, IP allowed list and the VPC network. Okay, so in the VPC network, we can have the VPC peering. Okay, so what exactly VPC peering means that we can create a peering between the Yugabyte Cloud VPC to your VPC of the application to allow the secure communication. Okay, so since we have AWS and GCP option, user can create the peering using provide the peering name, then provide the information. In case of AWS, user needs to provide account ID, VPC ID, region, and CIDR block, and initiate the pairing. Okay, so I already created one pairing here. If we go here, I provided this AWS details, including the VPC ID, account ID, then the CID block and the region. So once we initiate the pairing, what is going to happen is that based on the VPC ID provided, it will go a request under a particular VPC under the peering connection. So this row will be automatically populated. But what user need to do is that click here, go in the action and accept the request, so that these two VPCs should be able to communicate over here. So in my case, my VPC is now communicating to the Yugabyte Cloud VPC. So let me go here. I'll show you. This is the application EC2 instance VM, okay, which I have created, okay, where web application is currently running as well as the API are currently running. That is it from the network access side. Last option is admin, where I can invite different user to use this Yugabyte Cloud. So user has to click invite user, provide the email addresses and the role of the user, whether it should have developer or admin role, and accordingly this invitation will be sent out and user can use the particular cluster or the Yugabyte Cloud portal accordingly. I think that is it from the Yugabyte Cloud demo side. Finally, I will speak on customer case study. Admiral is one of the Yugabyte Cloud database customer, which is the leader visitor relationship management platform, which is serving thousands of publishers worldwide. Their use case was to have database backend for an identity and access management, that is IAM service, where their requirements were horizontal scaling, subsequent response time, encryption and rest, and in transit, which Yugabyte supports. You can get complete case study details with competitor and entire customer on the below link. Here is the production deployment which Admiral has on the production environment. Deployment is across the 5 countries and 3 continents. There is synchronous cluster across US West, US Central and US East, and 2 replicas in Asia and Europe. In a nutshell, I would like to say you bring the applications and we will handle the database operations for you effortlessly. So that's it from my side. Thanks for attending. Have a nice day. Thank you.